Now, one more interesting problem on pulley systems, but this time we have a movable pulley and a fixed pulley and two masses. So, as I have explained you before in previous videos, whenever there is a movable pulley, the acceleration for both the masses will not be same, so you have to be careful about that. So the statement, the problem is important for JEE Main and also JEE Advanced, and not for NEET, and also for different board examinations India and abroad, right? So the problem is taken from the book Concepts of Physics by Professor HCVerma from IIT Kanpur. Now let me now solve it and explain the situations in different derivations word by word. Now if you look at the diagram, now this is the original diagram. This mass is given as m and this mass is given as 2 times this 2m, and this angle is given as 30 degree, right? And the surface here is smooth, so there is no friction, and this string going over this pulley and again over this pulley is attached to a fixed support here, and this mass 2m is attached to this movable pulley. Now to explain it better, so first of all you must remember this is a movable pulley, this is a fixed pulley, so the acceleration of this mass and this mass 2m will not be same. So we have to be careful about that. And if you look at this string which is passing over, starting from here, passing over this pulley, then over this pulley is fixed here, the length of the string is fixed. The string is not stretchable. Means in whatever is the situation, means when this mass is here and this pulley is here, the total length of the string is still the same. Now let me first, without writing any equations, let us first find out what will be the acceleration of this and acceleration of this, how these two accelerations are related. Now, since the length of the string is fixed, I have redrawn another diagram here to explain you better. Before this pulley started falling down, this was its position, which I have shown it here. This is the position. Suppose this pulley falls down from this position to this position by a distance x. Then what will happen? This string which is going around this pulley in this new position, the string will be like this. The string will be like this, and the pulley has fallen down by a distance x. So the length of the string that will increase, so the available length of the string on this side that will increase is x on this side and x on this side. Means this part of the string will increase its length when this pulley falls down by a distance x. The increase in length will be 2x, and the same increase in length which is on this side, that will be reduced. So on this side there will be reduction in length, means this mass m will move to this side by distance 2x. So when this pulley falls by a distance, vertical distance by x, the string, the new orientation of the string around this pulley will be here, will be like this. Will be like this. So x on this side and x on this side, so 2x. And the same length 2x will be reduced from this side. Means if this pulley falls down by a distance x, this mass will be pulled up along the inclined plane by 2x, right? So if you different x with respect to time once, and you differentiate this with respect to time, so if the velocity of this mass is attached to the pulley. So if the pulley falls by a distance x, the mass 2m will also fall by the same distance x. And in the same time, this mass will be pulled up by a distance 2x, by 2x. So if the velocity of this mass to this side will be v, by differentiating this once, dx by dt is velocity. So if you differentiate this, the velocity of this to this side will be 2 times of this v. Now, if you differentiate this v once with respect to time, if the acceleration is a for this mass to this side, then the acceleration of this to this side will be 2 times the acceleration of this. So that is the conclusion. So if the acceleration of this is a, the acceleration of this to this side will be 2 times a. Now, once that is understood, then let us write the equations. Its mass is 2m, so its weight is vertically downward. Mass times g, that is equal to 2m times g. And what about here? I have already explained you, when a mass is on an inclined plane, its weight is mg, vertically downward. There is no need to show it here, but let me show it here. Its weight is mg, vertically downward, capital Mg. Now, which component of this force mg will be to this side? That will be equal to your mg times sine 30. Let me show it here. So, this is your mg times sine 30, and since sine 30 is 1 over 2, so this is mg over 2. Now, and this is 2 times mg. Now, then look at this string. It is the same string going over this pulley and this pulley. Now, so the tension all throughout this string will be same. So, if you consider this pulley, for this pulley the tension will be away from it, let it be T, same tension T. Now, it is the same string. So, for this mass, this tension will be to this side. So, this mass is now subjected to 2 forces. One tension is to this side and a component of its weight, mg, that is mg sine theta, that is equal to mg by over 2 is to this side. Now look at this. Look at this string, which is holding this mass from the pulley. Now, if nothing is moving, this is neither moving down nor moving up. This is neither moving down the incline nor moving up the inclined plane. Means, in that case is called equilibrium. So, what will the tension here? T plus T. T plus T, that is 2T. For this pulley to this side, for this mass it is equal to 2 times T to this side. Now, if you look at this mass, it is also subjected to 2 forces, 2 mg vertically downward and 2T upward. If this is not falling down or going up, then that condition is called condition of equilibrium. So, in that case, you have to write 2 times T is equal to 2 times mg. And in that case, you have to write here, if this is not going up or coming down, then T is balanced by mg by 2. So, here you will write T is equal to mg over 2. But since in the question, we have asked to find the acceleration of the block of mass m. What is the acceleration of this? So, there is a net force. So, there is a net force. Now, now look. So, how to write the equations? Now, now look here, if this is going up, therefore T has to be more than this. So on this, the net force is equal to, let on this, the net force is equal to T minus mg over 2. T minus mg over 2 is the net force on this to this side if it is moving up. So that will be its mass times its acceleration, and its acceleration is 2a, which I have already explained. So m times 2a. So let me rewrite it. So T minus mg over 2 is 2 times ma, equation 1. Now if you look at, since this is going up, therefore this mass will fall down. So your 2 mg must be more than 2t. Then there will be a net force to this side. So, and the net force will be its mass times the acceleration. So for this mass, I write 2 times mg. I write it here, 2 times mg minus 2 times t will be equal to its mass 2m times its acceleration is a. So if you rewrite, this comes out to be 2 mg minus 2 times t is equal to 2 ma. That is your equation number 2. Now let me encircle this with red for better visibility and encircle this with red. Now look at the right hand side of the equation 1 and equation 2. 2 ma and here also 2 ma. So the left hand sides will be equal. So the left hand side of equation 1 will be equal to the left hand side of the equation 2. So now we can solve it. So I write left hand side of equation equal to the left hand side of the equation 2. So to do it faster, so T minus mg over 2 is equal to 2 mg minus 2t. Now bring this 2t to the left hand side, it will be added to this, so we will have 3 times the tension, 3t. This comes to the right hand side, so that is equal to 2 mg plus mg over 2. So that becomes, you take your LCM, so 4 mg plus mg, that is equal to 5 mg over 2 is your this. So your T comes out to be, this 3 comes to the right hand side, so is equal to 5 mg over 6 is your tension. So T is equal to, so your T is equal to 5 mg over 6. Now put this value of T either here or here to find the acceleration. So let us put it here. Let me rewrite this in here. T minus mg over 2 is equal to 2 times a, that is equation 1, and T we have just found out as 5 mg over 6. So for this I write 5 mg over 6 minus mg over 2 is equal to 2 times ma. Now if you take LCM, is 6, so 5 times mg minus 6 divided by 2 is 3, so 3 times mg is equal to 2 times ma. Now 5 mg minus 3 mg is equal to 2 times mg over 6 is equal to 2 times ma. 2 is multiplied here it cancels. Now your mm cancels. So I am on the right hand side only left with a, acceleration. So acceleration is equal to g over 6. So acceleration is equal to your g over 6. So that is all about. Now if you want to find the tension, you can put it here. So your tension will be 5. There is no need. The tension is free from any acceleration. So the tension is equal to 5 times mg over 6, and your acceleration is g by 6. Now, but a was the acceleration for this mass, and for this mass the acceleration was 2a, and in the question it has asked to find the acceleration of this mass. So it will be 2 times this. So the acceleration for the mass m will be equal to 2 times this, that is equal to 2g over 6, that is equal to g over 3 meter per second square. Right? So acceleration of the mass is g over 3, this mass, which is 2 times this acceleration, and this is the acceleration of this mass, right? So that is all about. If the things are interesting and you find the explanation interesting for you, feel free to subscribe and pass on to your friends. Thank you.